In this video, we are going to see about why the alternators are rated in KVA. Let's see with an example. So here the alternator is going to supply for the loads. So we know that the loads may be any kind. So maybe a home appliances or a motor or lighting or a fan system. So you might know that these loads are may be resistive in nature, inductive in nature, or capacitive in nature. Okay, according to the load, the power factor varies. For example, the resistive load, the power factor will be unity, and inductive, there will be a lagging. If it is a capacitive load, it will be a leading power factor. Now the alternator doesn't know, or the manufacturer doesn't know, what kind of the load the customer is going to be used, and also they don't know about the what kind of the power factor is going to be fit to the alternator. Okay, so now this generator assumed to be 100 kVA power rating. Okay, 1 kV is the voltage rating and 100 amps will be the, this is 100 amps. 100 amps is the maximum current rating. So it's going to deliver a load. Okay, the load power we can calculate P equal to root 3 VL IL cos phi. Okay, now assume that the voltage here is 1 kV. Okay, so we do not consider the root 3, just for a discussion we will take only VL IL cos phi. Okay, now if it is working on unity power factor, then the current is going to be 100 amps. So I am not considering the root 3 now. Suppose the load is working at 0.5 power factor, the current is going to be 200 amps. 200 amps. If it is going to be operating 0.1, is going to be 1000 amps. Okay, now you consider here, if it is working on unity power factor 100 amps, if it is a 0.5, it is going to be 200 amps. 0.1 meter, if it is a, if it will be take 100,000 amps from the generator. Okay, when the alternator is manufacturing, there are two things will be considered for the voltage and the current rating. Okay, so here the first thing is insulation, that is directly proportional to the insulation, that means directly proportional to the voltage. So this alternator is designed for to have a 1 kVA insulation rating, and if it is more than 1 kVA, definitely there is going to be a damage. So some acceptable levels are there, maybe twice time, but we'll consider here 1 kVA is the maximum rating, so that if it is more than 1 kVA rating, definitely is going to be damaged. That means the insulation is going to be break out, and so that the short circuiting going to happen in the alternator. So finally it's going to be damaged. Similarly, the second thing is current carrying capacity of the conductor. the current carrying capacity of the conductor decides the conductor size. So the conductor size will be chosen based on the 100 amps here. So if it is more than 100 amps, is going to be damage the alternator. Okay, so based on the two things, we are going to make the alternator, and other parameters will be considered, but we will consider only this voltage and current for the purpose. Also, you have to know that the losses, there are two losses mainly. One is the copper losses and the iron losses. Other losses is like when it is rotating, since it is a rotating machine, the windage and friction losses will be there. So if it is a electrical losses, that is directly proportional voltage and current, means one is copper losses and another one is iron losses. Copper losses directly proportional to current, iron losses directly proportional to voltage. So if you notice here, the copper loss is going to be decided by the current rating, and the iron losses going to be decided by the voltage. So the losses will be the will increase the temperature. So further the losses increases, the temperature also increases. That is going to be dissipating the heat form. Okay, so if you notice here, this copper loss or the iron loss, it is independent of the power factor here, the first thing. Second thing, these voltage and the current rating, that is decided for the maximum power rated to be delivered for the loads. Okay, so similarly you consider the load side, the power equal to VL IL cos phi. So to be the namesake, we will take it VL IL cos phi. So if it is a 1 kVA rating, the voltage is not going to be changed for all the power factor. But if you see the current rating of the load that will be delivered from the alternator to the load will be 100 amps if it is a unity, 0.5, that means if it is a 0.5 power factor, then it is going to be a 200 amps. If it is a 0.1, it is going to be a 1000 amps. Okay, now if you see, the load power depends upon the power factor. That means the current drawn from the alternator is going to, that is depends upon the power factor. Okay, suppose if I am giving it is in the kilowatt, so the kilowatt only a real power, and this will not, this real power, it is depends upon the cos phi. Okay, so I am the manufacturer of the alternator will not know what kind of power factor is going to be operate. Okay, so if it is a unity power factor, it draws less current. If it is a uh, 0.1 power factor, it 10 times more the current, so that the current will not be delivered by the alternator. Okay, so here there are two things we have to consider. One is the loss, that is independent of the power factor. Second thing, this is manufactured for the maximum insulation and current level, not for the power factor. So that is why these alternators are mentioned in the VA or KVA, that is a kilovolt ampere, or MVA rating. Okay, thank you. Now the load capacity, that means the power rating of the load, is 100 kilowatt. So if it is a 100 kilowatt, that is the 100 kilowatt has to be delivered from the alternator. Okay, so but this load can be operated at any power factor, maybe from 0.1 to unity power factor. Okay, so the for the all the power factors, the load the alternator can give, but it can offer only maximum 100 kVA as the power, because the 100 kVA, that means the 1 kVA is the maximum rating of the voltage and the 100 amps is the maximum current capacity of this alternator. So together, all together, that is apparent power 100 kVA can be delivered. So this 100 kVA includes the total power, that is an apparent power, real and reactive power. So the load value only takes the real power, but the reactive power also has to be supplied by the alternator. So if it is operating under low power factors, the reactive power will be more, so that cannot be supplied by the alternator if it is the going beyond their limits. So that is way this alternator is given in the KVA rating. So now we can decide that, so the losses are independent of the power factor, and the voltage and current decides the insulation and the current carrying capacity and heat capacity also. So that is way these alternators are given in the KVA rating.